Okay, hi guys. So I'm going to show you how to write a function called uniqueArray, which takes an array and gives back an array with all the items being unique. So you can see I have this array here and it has a duplicate here. So it's going to return, our function should return to us a unique array, which is going to be just 1, 2, 3. So I'm going to show you how to do this a couple of different ways. The first solution, uniqueArray1, we're going to write this using a higher order function, which is basically a function that takes a function or returns a function. And we're going to use filter. So we're going to do a.filter, and filter takes a function that takes up to 3 parameters. So we're just going to use the first, which is element, and then its index. And it's going to return to us. So filter is going to takes a function that returns a Boolean value to indicate whether or not to include the element. So we're going to do a dot index of this element and check if it's equal to that index. So basically what this is going to do is for 1, the index is 0, so it's going to come in, the element is 1 and the index is 0, and it's going to check this index of element 1 in this array A, which is 0, and see if that's equal to 0, which is true. And the same is going to happen for 2. Now for the second 2 here, what's going to happen is it's going to come through, so the element is 2 and the index is going to be 0, 1, 2. So element of 2, index of 2, and then it's going to check index of element 2 in A, which is going to go to this 2, because what index of does is it goes front to back. So that's going to be 1. And is 1 equal to 2? No, it's not, so it's not going to include the second 2 here. So we can check if this works. I've written a test down here. And you can see that indeed it does return to us a unique array. So let's see. So the thing here though is it does create a closure over A. This function here creates a closure of A. In order to not do that, what we could do is we could use the third parameter, which is itself. So filter takes a function that has these 3 parameters, which is the element we're looking at, its index, and then this entire array. And then we're going to change this to self. And you can see it still works. I'm going to build it again, and you can see that it works. So this avoids creating a closure over A. So now with our second solution, I am going to instead, for this second solution, we're going to use a hash table, because although this solution looks quite elegant, it's not the most efficient. So for instance, the time complexity here is actually going to be quadratic, because filter is going to be linear. We're going to go through each one of these items, and then index of is actually linear. So that makes this entire function of n squared, which is quadratic. The space complexity, however, we don't actually store anything, so I'm going to say none or constant. Okay, so now for this next solution, we're going to call it uniqueArray2. It's going to also still take an array, and instead of using just filter, we are going to store everything into a hash table, which in JavaScript can just be an object. So we're going to call it scene, and we're going to utilize that. So we're still going to use filter, so I'm going to go a.filter, and we're going to use just the element this time, a function that just takes the element, and we're going to do scene.has own property, and then use L. And basically what this does is it's going to check scene, and it's going to check if it has a property named L, which it's going to cycle through every element here inside of our array. And if it has seen it, well, we're going to return false so that we don't include that element. But if not, then we are going to store it in scene. So, and we'll just say it's equal to true. And lastly, so this is going to, obviously filter is going to produce that unique array. It's going to take everything in A, and it's going to create, the output is going to be our unique array, so we're going to return that. And we could test this out here. Let's see. And you can see that also works. Okay, so for our third solution, basically these function calls are quite expensive, so we're not going to use filter, and we're going to, for maximum performance, replace filter with a loop instead. So let uniqueArray 3 okay, so we're still going to use a hash table. Let's call it, we're going to call it scene, and then we're going to have an out equals just a regular array. Yeah. Oh, and just so we don't forget, the time and space complexity for the second solution, you can see because we use the hash table is going to be substantially better. Hash tables, or objects in this case, have a constant time axis. So filter is linear, and this everything inside is constant, which is just going to make this constant. So this is, linear. And then again, we don't really, oh actually, no, we do store something this time, and we store it inside this object, so now it's going to also be linear. There we go. Okay, so now for the third solution, it's going to be an order of magnitude faster because we're not going to use filter and we're replacing it with a loop. So we're going to say, we're going to loop through A. Okay, length. So we're looping through all the elements at A, and we're going to say if we have not seen A in scene, then what we want to do is push that element, and this element, let's call it L equals, that is our current element, and we're going to push L. And then we are also going to store L in scene. So let's go, and we can just say it's equal to true. And then when this loop finishes, it will have populated out with all of the unique elements, so we're going to return out. Okay, and we will test this out as well. So here we go. Oops. And let's run that. Oh. What happened? Okay, so let's try to debug this. It's coming through. We are looping through everything in A, and then we are saying if we have not seen, oh, here we go. Here is our problem. That's not what we're looking for. we are going to do that, we're actually looking for L in scene. There we go. Oops. And we can see that works. Okay. So now we're at the next solution, 4. And basically, for this solution, I am going to just use ES6 to do it. Now, we're going to use ES6 is 6, oops, set object. Okay, and the set object is basically creates a unique set. So the solution becomes very simple. So we just let uniqueArray 4 equals, and again it's also going to take A, and instead we're just going to directly return an array using the spread operator to create a new set of A, and that's it. And so basically this creates a new set using A, so it's going to go through every single object element in A and create a unique set with that. And then what the spread operator does here is it's just going to expand it out. So each element is going to be an element of the array. And we can save, and you can see, actually I don't need this, and save, and then boom. And you can see that works as well. If we wanted to test this with a different, let's see, a different data point. So array equals, we can do Mississippi dot split. This is going to be an array here. I'm going to save, and build. And you can see that it works for that as well, because Mississippi is going to, this array is now going to be an array where every letter in Mississippi is an element in that array. So here it's returning to us only the unique letters, MISP. There we go. Okay, well, thanks for watching. If you guys have any questions, suggestions, or corrections, if I made any mistakes or anything, please let me know. Thank you for watching. Okay, bye.